Here we're going to take a look at an example where we are going to do a hypothesis test for a population standard deviation. So here we have a simple random sample of 36 cans of Coke, has a mean volume of 12.19 ounces and a standard deviation of 0.11 ounces. They appear to be from a normally distributed population. If we want the filling process to work so that almost all cans have a volume between 11.8 and 12.4, then the standard deviation should be less than 0.15. Use the sample data to test the claim that the population has a standard deviation less than 0.15 ounces. We are going to use a 0.05 significance level. All right, so we have test the claim. The claim is that the standard deviation, sigma, is less than 0.15. So then we identify the opposite of the claim, and it's not less than 0.15. It's actually the opposite. It is greater than or equal to 0.15. From these two things, we will use those to come up with our null and alternative hypothesis. The alternative is always the one that does not allow the two sides to be equal. And so that's going to come from the claim in this particular example. So sigma is less than 0.15. And sigma is equal to 0.15 will be the null hypothesis. Remember, the null is always a statement that a population parameter equals some other value. We are also given here that the sample size n is 36. We're given a sample mean there. We don't actually need it. That's extra information that's not super important when we go through this process. We have a sample standard deviation that is 0.11. They give us all this information about needing the volume to be between 11.8 ounces and 12.4, and that's really just to establish that the population standard deviation should be less than 0.15. It's the motivation for this particular test. So those values, the 11.8 and 12.4, those are not needed for us to go through and do this test. The only other thing that we need to do is the significance level. So alpha is 0.05. So this is going to be a chi-squared test, a test that uses a chi-squared distribution. So for a chi-squared distribution, it looks something like this. Our alternative hypothesis is that the standard deviation is less than some value. And so this is a one-tailed test. Specifically, it's going to be a left-tailed test. And that area of 0.05 is going to be all in this left tail. So if we're in that left tail, we want to reject the null hypothesis. If we're not in that left tail, we will fail to reject the null hypothesis. All right, so let's look at our p-value. So we're going to go over to StatDisk and we're going to input these things and come up with a p-value. So analysis, we are doing hypothesis testing. And our hypothesis testing, sorry about that. So analysis, hypothesis testing, and we have a standard deviation with one sample. So that's what we're going to choose. Our alternative hypothesis is that the population standard deviation is less than some claimed value. Our significance level was 0.05. Our claimed standard deviation was the value from our null hypothesis, so it's the 0.15. claim that the standard deviation is 0.15. The sample size, I believe, was 36. And the sample standard deviation was, I think, 0.11. Yep, 0.11. So we enter those values in, and then we can evaluate. And here we are going to do the p-value method first. So our p-value is 0.0116. We observe that 0.0116 is less than our significance level. If the p-value is low, the null must go, so we reject the null. And so there is evidence of the alternative, which our alternative hypothesis is there is evidence that the mean is, or the standard deviation is less than 0.15. In terms of that chi-squared distribution, for that chi-squared distribution, what we've really done is we've said this 0.116, that's all right here. Because 0.116 is less than 0.05, we are in this region of rejection. We are in that tail. We can identify that we're in the tail using a critical value method as well. So using a critical value method, we should only have one critical value. It should be a chi-squared value. We should have one test statistic. Should also be a chi-squared value. So our critical chi-squared is 22.465. And our test statistic was 18.822. And so, since that test statistic, 18.822, happens to be smaller than our critical value, 22.465, then we are going to reject the null hypothesis. We are in that region of rejection. Now, some of you might say, I thought I remembered looking at other videos, and you said if that critical value, if the test statistic was greater than the critical value, we rejected. And that's true. I did say that in the other videos. That's because in the previous videos we had looked at a right-tailed test. And so you have to be really careful about the type of test, if it's a left-tailed or right-tailed test, when you're making this determination based on critical value. So we reject the null. Because that critical value here, that test statistic is below the critical value in this case, and we have a left-tailed test. And then the final thing that we're going to do is we are going to do a confidence interval method. So back over there at StatDisk, we have our confidence interval. We're doing stuff with standard deviation. So here is our confidence interval standard deviation, 0.092 to 0.137. 0.092 to 0.137. And we observe that this hypothesized alternative hypothesis, or this null hypothesis 0.015, that does not actually live in this range. This whole confidence interval right down here is all below 0.15. So there is evidence of the alternative, that is that the standard deviation is less than 0.15 because that entire confidence interval is below 0.15. All right, next time we will get into looking at how do things work when we have two different populations that we are looking at. We'll talk to you guys later.